One of my last videos, in case you didn't realize, was a complete joke of a video. I made a joke about feeling left out of David and Seon's Cobb LED segment display projects, and also I made a joke about receiving a part from BLC PCD. But that part is for a project that was inspired by the work that Seon and David were doing. I did a project last year where an ESP8266 fetched live traffic data from Google Maps and it displayed on a map which was the fastest route home. One of the pieces of feedback that I thought was really interesting on that project was, wouldn't it be cool if you could light up the entire road based on the traffic rather than just having LEDs along it? That suggestion brought me to Lightpipe, which is a material that illuminates if you shine an LED in either side of it. I never got around to trying it out though, so I was wondering, could you make a 7-segment display out of it? I started by designing some parts that would hold the light pipe in one end and a 5mm LED in the other. I revised my design a couple of times because initially my printer was struggling to print it and it was too weak. I also made it smaller because it didn't need to be as tall as I had it originally. Once I was happy the holders were working out okay, I then used them to create a 7-segment display shaped design. For the LEDs, I used 14 of these clear, through-hole, 5mm addressable LEDs, but there's a problem. I can't find where I bought them. I also can't find any more of these on AliExpress or eBay. I can only find the frosted ones, which I'd imagine will probably work but aren't ideal. I found some on SparkFun, but if you knew where to get more, if you wanted to let us know in the comments below, I'd really appreciate that. Next up is soldering the LEDs, but I need to warn you, this is not pretty. Originally I intended to do the soldering the same way I did in the maps project. I kept the D in and the D out flat to the board, and then kind of kept the VCC raised and up and the ground raised and to the bottom. This worked out pretty good, but I had a lot of space and I was able to keep the LEDs all facing in the same direction. I started by soldering the D-ins to the D-outs of the next pixel, and that started okay, but because some of them were so close to each other, I couldn't keep them facing the same direction anymore. I did manage to push all the ground legs in towards the center and all the VCC legs out towards the edge. But I was feeling pretty lazy, so rather than stripping a lot of wire, I used a single strand of bare wire for ground and a single strand around the outside for VCC. So this is the result. Yeah, not my finest work, but I did test it for shorts and it seemed okay. I really wouldn't recommend doing it this way. This is a short waiting to happen. If I was doing it again, I'd probably use perf board or something on each LED. That would make connecting them up a whole lot easier, or even better, if you designed a board up to do it, that would be best. I did put some electrical insulating tape on the VCC line just to help protect against shorts. Next thing we need to do is measure and cut the light pipe. I'm using a Stanley blade out of the knife. You can see here that I started kind of sawing at it, but I found towards the end that just pressing it down like a guillotine works much better. You don't need to be too exact with the lengths that you cut this because there's a good bit of wiggle room built into the 3D print. If anything, I'd leave it a little bit long rather than too short because it makes it easier to push into the holes. Also, you can trim off a little bit extra if it is too long. I ended up cutting 8 for some reason. Apparently I can't count to 7. Insert the light pipe into both holes for each segment and push it in as far as you can. Even before turning it on, I was really happy with how it came out. It looked kind of cool. These LEDs default to blue when you power them up, so I was able to test that everything was working without hooking it up to an Arduino. I then hooked up the display to an Arduino Uno. I connected D in of the first LED to pin 10, ground to ground, and then VCC to V in of the Uno because I'll be powering it using USB. I'm sure there's a better way to write this sketch, but I defined the segments in an array up the top, and then I used a switch statement that based on the number that was passed in, it would set the segments that were needed. And the result looks a little something like this, and I have to say I'm really happy with it. I think it looks really good. It doesn't just work in dark conditions either, it actually looks pretty good in the daylight too. The right hand side of your picture is on my desk under two bright LED lamps that I use for recording the videos. To summarize the experiment, I'm really happy with the effect, but not the implementation. With the mess of the wiring and the scarcity of that type of LED, if I was doing this again, I'd definitely use a board with SMD neopixels. Any guesses what's in the package? Hopefully you enjoyed this video, and if you have any feedback or suggestions, I'd love to hear them in the comments below, and I'll see you next time. Thanks a lot.